Okay, simple drug calculations. If you are looking for an easy formula to remember, this might be it. It is called the desired over have formula. Desired over have formula. And if you already have a drug calculation formula that you use and it's not this, there are still some simple practice questions that you could do throughout. So let's go ahead and get started. Hopefully by now you have put these to memorization. If not, certainly these are the basics or the minimal conversions that you would need to know by memory in order to be successful on a drug calculation exam. So go ahead and start to memorize these and then add as needed for your School of Nursing or for HCC. Okay, so desired over have method helps us to calculate needed dosages when we have a prescription and we know what the dose is that is available. For example, if you have Haldol, 1 milligram prescribed by mouth 2 times a day, and the pharmacy sends you 0.5 milligrams per tablet, how would you do this calculation? We can use the formula that we call HV equals dx. The H stands for have. What do we have? The V stands for volume. What is the volume, such as tablet or milliliters? Equals, the D stands for desired. What is it that you desired? And we are solving for X. So with the Haldol, what do we have? It tells us right here what's available is 0.5 milligrams per tablet. So you have 0.5 milligrams and your volume is a tablet. What do we need? Well, what was prescribed? 1 milligram, and we're solving for X. For the desired over have, the inside numbers go on top. So for instance, what we're talking about here, the inside go on top. We're talking about the 1 tablet times the 1 milligram. So we all know if we do 1 times 1, it equals 1. Okay? And the outside numbers, which is the 5 milligrams and the X, go on the bottom. So what we end up having is your top was 1 times 1, so on top is 1, and on the bottom we had 0.5 times X, so that's 0.5, and now you have a simple division problem. And so this is pretty much how it always works. Top numbers are on top, or your inside numbers are on top, your outside numbers are on the bottom. And this is how it works. And so then you simply have your calculation of 1 divided by 0.5. And so we know in order to give the 1 milligram, we need to do what? We need to give 2 tabs or 2 tablets. Okay, so let's try the HVD X method. So what do we have? We have 50 milligrams, right? So that's what we have. That's your H, 50 milligrams. All right. What's our volume? We know tabs, so there's 1 tab. What do we desire? Well, up here, the doctor has ordered 100 milligrams. And we're solving for X. So we know we get rid of the milligrams, they cancel out, right? So we know we're solving for tablets. So what did we say? We said the inside numbers go on top, right? So the inside go on top of our equation. So what do we have? We have 1 times 100. So we know we have 100 on top, and then the outside numbers go on the bottom. So 50 times X is 50. And so once again, what do we have? We have a simple division where you just need to take 100 divided by 50, and we know that we need to give 2 what? We're solving for tablets, 2 tabs. Okay, so digoxin. What do we have ordered? We have 250 mics of digoxin ordered by mouth every day. And so what do we have? Over here, it tells us that we have 125 mics. And what is our volume? We know that we have tablets. So that's in 1 tab. What do we need? Or what is desired? We have 250 mics. And we're solving for x. So once again, the top number is the inside. So 1 times 250. And then on the bottom, once again, 125 divided by x is 125. And so what you have here, again, is a simple division problem where you're dividing 250, right, by 125. And once again, you get 2 tabs. We know that the units is tabs because remember the mics cancel out. Okay, so this one is a little bit different. If you look here, we need to determine what we have and what the volume is. And as you can see right here, we actually have 250 milligrams, but see, it's in 5 mLs. So this answer is going to be in 5 mLs. What do we need, or what is the desired, is 375. And then we're figuring for x. So milligrams would cross out, and we would be figuring mLs. So you actually have to take the 5 times the 375, and then you would divide that number by the 250. And so what you would end up having is 7.5 mLs. So there's a point right here, 7.5 mLs. Because what you had to do in this particular case was add the 5 mLs to the volume because it wasn't just a tablet. And so we had to take 5 times 375. And so when you take 5 times 375, then that gives you the 1875, and divide that by the 250, that gives you 7.5 mLs. So we would need to pour this patient 7.5 mLs of their amoxicillin. All right, so this person needs Motrin, and they need 125 milligrams. And so if you expand this view, it looks like we have 100 milligrams per 5 mLs. So 100 milligrams per 5 mLs is what we have. So what do we have? We have, let me get my pen up here. We have 100 milligrams. What is our volume? Per 5 mLs. What do we need? 125 milligrams. And we're solving for x. Okay, so I'm going to give you a second to set this up to see if you understand how to add in the volume, to make sure that you add that in. So go ahead and set up your problem. Okay, so the inside numbers go on top. We know the milligrams cancel out. Outside numbers go on the bottom. So that's how you should have set this problem up. Now go ahead and figure it out. Complete the actual calculation. and your answer should be 6.25 mLs. So this person, in order to deliver their 125 milligrams of Motrin, you would pour 6.25 mLs. There are going to be times that you're going to have meds ordered based upon a patient's weight or weight-based medication administration. So there are a couple of extra steps. The first one is, do you need to convert it? Do you need to convert the weight? Is the weight ordered in pounds or kilograms? And what is your patient's weight in? And that determines. Once you determine or calculate the patient's weight, then you'll need to calculate the actual dose. An example would be, let's say a physician orders 1 milligram of Demerol per kilogram and the patient weighs 125 pounds. What are your extra steps? Well, if a physician is going to order medicine in kilograms and your patient's weight is in pounds, then you need to convert the pounds to kilograms. So we would need to take the patient's weight in pounds, which was 125, and divide it by the known conversion, which is 2.2. And this will give us kilograms. For instance, this will give us 56.8 kilograms. So it's an adult, so we know we can round up. So then we know we now have 57 kilograms. And the physician said 1 milligram of Demerol per kilogram. So you would just take the patient's weight, which is now 57 kilograms times 1, and the desired dose of Demerol is 57 milligrams. So let's say that the pharmacy sends you 25 milligrams, okay, per 1 ml. And what was your desired dose? Desired was 57 milligrams, right? And we're solving for x. So your insides go together. So 1 times 57 is obviously 57, and 25 times x is 25. We know that the milligrams cancel out, and we are therefore figuring for mLs. And so you have a simple calculation of 57 divided by 25, and this patient needs 2.28 mLs of Demerol to receive the correct dose. So the patient needs 2.2 mLs of Demerol for the patient to receive the correct dose. And that's how you do weight-based calculations. Okay, let's work through this one. So a physician orders 0.1 milligrams of morphine per kilogram. We have 130 pounds, so we know that we need to convert that. So that's obviously our first step. We would take our 130, right, pounds. We know we need to convert it to kilograms, so we would divide it by the 2.2. We know that's the known conversion, and we have 59. So this patient weighs 59 kilos. Okay, so that's kind of your step one. Well, then we have to figure out what's the desired dose. So then we have to take that 59 kilograms times what the physician ordered, which was 0.1. So if we take 59 times 0.1, then we know we need 0.59 milligrams. And that is a weight-based calculation. That is our desired dose. So let's say then the next step is pharmacy sends us 4 milligrams per morphine in 1 ml, and we know we need 5.9 milligrams, and we're solving for x. And we know our milligrams cancel out. We know 1 times 5.9, or our inside numbers, is 5.9, and our lower numbers go together over 4. And so we have 5.9 divided by 4. And so this, excuse me, so we have 5.9 divided by 4. And so this patient would receive 1.475 or 1.5 mLs of morphine. Okay? So we would not take and round this down. We would take this number here and round based upon that, and it would make it 1.5 mLs. 1.5 mLs. All right. Go ahead, get a scrap piece of paper, calculator, and set and do these to the best of your ability. And then we will go over the answers. So when you're ready, just click stop it here, and when you're ready, then restart. Okay. First question had to do with Lasix. There was 10 milligrams per ml, and we needed 40 milligrams. And so we ended up needing, the correct response was 4 mLs. Next was heparin. We needed 7,500 units. The pharmacy sent 10,000 units per ml. And so the answer was 0.75 mLs. Remember, you need to make sure that you lead with your 0. And also think about the fact that if you're going to give this sub-Q, it should be given in a small tuberculin syringe so you can get the exact dose. Next had to do with Aldament, and you needed 250 milligrams, and it came in 500 milligrams per tab, so we need to give a half of a tablet. And again, make sure you lead with the 0. The last was a weight-based. Your patient needs Lovenox. They weighed 170 pounds, and the order was in kilograms, so we needed to convert the pounds to kilograms. Came out to be 79.9, so it's an adult. We rounded to 80 kilos. The physician ordered for the Lovenox to be given 1 milligram per kilogram, so we took the 80 kilograms and times it by 1, and so we need 80 milligrams of Lovenox. The pharmacy sent up 40 milligrams per ml, and we needed 80, and so the patient will receive 2 mLs of Lovenox. All right. All right, class. If you need more practice, just shoot me an email, okay? You can email me at, let me write it down here for you guys, pstiefvater at hccfl.edu. So that's pstiefvater at hccfl.edu. If you feel like you need more practice sheets, just email me, and I'll be glad to email them to you. Thanks.